So hello friends, today I'm going to talk about the type 2 or the second type of problem which comes from the signal flow graph. And here we find that there a block diagram is given, and from that we have to get the transfer function of that system. Previously I have told that how the nodes and the takeoff points, using those formulas, using Mason's gain formula, how you have to find out the transfer function. If you have not watched my first video on this, you please check it out, the link is in the description, and then you come for this problem, because here I am converting it first in the signal flow graph, then I am applying the Mason's gain formula and finding out the transfer function. So let's read the question once. Find the transfer function of the given block diagram using Mason's gain formula. So we know that directly from this block diagram we can't apply the Mason's gain formula. First we have to convert it into signal flow graph, then we can apply the Mason's gain formula and find the transfer function. So let us first convert it into the signal flow graph. So previously I have told you that all the adding points or the summer will act as a node of signal flow graph, and also the takeoff points will act as node in the signal flow graph. So according to that, let us draw the signal flow graph. So first I have drawn all the nodes of signal flow graph. You can understand it very easily. If you see here, the first summer I have taken it as node 1, means this will be node 1, and the next one, this will be node 2, as it is a summer. Here we find a takeoff point, hence we can take it as node 3. Then this will be node 4, this summer will be node 5, this takeoff point will be node 6, and finally I have taken the output part here as a node. You can take it or you cannot take it, it is your decision, but mainly you have to take the summer and the takeoff points as your nodes. So finally we have found that there is 7 nodes here. Now I have to draw the complete signal flow graph, and I can find that between 1 and 2 their gain is 1, and between 2 and 3 there is as G1, I have to take G1 as gain. I find a feedback, and the feedback type is negative feedback, hence I have to take the feedback like this. As it is a negative feedback, it will be minus H1. From 3 to 4 there is G2. From 4 to 5 there is actually 3 paths, 1, 2 and 3. The gain of the first path is G4, this is G3, and this is G5. Between 5 and 6, this part you have to understand it, this is very important. Sometimes students ignore this part, and this actually will be a fault if you don't take it in the calculation of loops and all. So between 5 and 6 the gain will be 1, between 6 and 7 the gain will be G6, and finally we will get the output. So from 6 we can find another feedback path which is going to 1, and this is also a negative feedback, hence here the gain value will be minus H2. So now we have to calculate the similar way. Previously we have calculated the Mason's through the Mason's gain formula, the transfer function. So in the same way we have to calculate the transfer function now. So first we have to find out the number of forward paths. So let's see. Here the number of forward paths is actually 3. 1, 2 and 3. This way. As it is a feedback path, we can take them as forward path. So here the number of forward paths is equal to 3, means the k value. The k value in the Mason's gain formula is 3. We have seen that Mason's gain formula as the transfer function value will be summation k, number of forward path, pk delta k by delta. Here k value is 3, means p1 delta 1 plus p2 delta 2 and p3 delta 3. p1 value is the forward path gain of forward path 1. Delta k will be the value of 1 minus the gain of non-touching loop of the first forward path. So later on we will find out the delta k value. First let us find out the forward path gain values. So first forward path gain, that is p1 is equal to g1. We can multiply the 1, it will be 1 actually, so finally it will be g1. 1 into g1 into g2, I am taking this path, into g3 into g6. In between there is 1, so it will be actually the value, the multiplication of g1, g2, g3 and g6. Second forward path gain, that is p2, will be g1, g2, g4 and g6. You can see it here, g1, g2, g4 and finally g6. And the last and the final third forward path gain will be p3 is equal to g1, g2, which one is left actually, g5 and g6. Now the most important part, to find the delta value, I have to calculate the loop gains. Here we can see that there is actually 4 loops, that is one loop, this one is one loop, this big one is another loop, so this is loop 2. Now the another 2 path will be very important, you have to notice it. This will be another loop and starting from here this will be another loop. So total there is 4 loops. So let us calculate the delta, that will be 1 minus L1 plus L2 plus L3 plus L4, and there is no 2 non-touching loops. Every loops are each and every loop is touching one another. So there is the value of non-touching loops will be 0. So now we can easily calculate the loop gains. So L1 can be G1 H1, as H1 value is actually it is minus H1, it comes from G1 into minus H1, hence this is minus G1 H1. I am writing directly L2 value will be minus G1 G2 G3 H2. L3 value, which is this one, taking the G5, this one means it will be G1 G2 G5 and minus H2, means finally it will be minus G1 G2 G5 H2, and L4 the final one will be minus G1 G2 G4 H2. For this one minus sign will be here. So now everything is prepared. Now we can apply the Mason's gain formula and find out the transfer function, and that will be transfer function using Mason's gain formula is equal to delta 3 pk delta k by delta is equal to p1 delta 1 plus p2 delta 2 plus p3 delta 3 and the delta value. Here p1 p2 p3 value we know. As delta 1 value we can find out 1 minus the non-touching loop gain of first path, as each and every loop is touching the first path, hence the value will be 0, 1 minus 0. So finally the delta 1 value will be 1. Similarly, delta 2 and delta 3 values will be 0 if you see it. So delta 3 value will be 1, hence the value will be p1 plus p2 plus p3 and 1 minus L1 plus L2 plus L3 plus L4. Now if you put the calculated values with the gain values, you will find out the transfer function of these problems. So put it yourself and you will find out the transfer function. If you have any question according to it, you can comment down below and ask me. I'll help you out. And if you like the video, please subscribe and like and share with your friends who need this control system the tutorials. And thank you so much. In my next videos, I'll be uploading the another 2 types of problems which come from Mason's gain formula. And subscribe, and as soon as I upload them, you'll get the notification. Thank you.